Hello children, welcome to channel Sube. Children, today I am going to discuss question number 46 from the MCQ part of 2021 Physics New Syllabus paper. A battery of e.m.f, electromotive force 12 volt and internal resistance 2 ohm is connected to two devices X and Y as shown in the figure. The resistances of X and Y are 6 ohm and 3 ohm respectively. When the devices are in operation, what is the power consumed by each device X and Y respectively? Children, this question is a very easy one, so let us do it. Children, first I will explain how to do this the short method. I will show you the short method. That means most of the things are done by heart, most of the things done in the head, on the paper. Very little thing we have to do. So these are resistors. So the current flows from this positive side and divide into two parts, and again they get together at the end of this resistors and go to the battery. So therefore these resistors are in parallel, connected in parallel. So we have to find out the current. First of all, this current, first we have to find out this current, and then we have to find out each these currents. So therefore the values 6 and 3, the resistances are 6 and 3. So the equivalent resistance is the multiplication divided by the sum. So 6 times 3 is 18, so the sum is 9, so divided by 9 is 2, so the equivalent resistance is 2. So 2 plus 2, the internal resistance is 2, the total resistance is 4. So the current I is 12 divided by 4 is 3 ampere. So here the current is 3 ampere. Then it is divided into these two parts according to the ratio, but not exactly the ratio, the inverse ratio. So the ratio of this resistance is 1 to 2, but the current divides the inverse 1 here 2. So altogether the current is 3 ampere. Therefore this 1 is ampere, 1 ampere here and 2 ampere here. Now altogether 3 ampere is okay. So here in this 6 ohm resistor, the current is 1 ampere. 3 ohm resistor, the current is 2 ampere. So what we want is the power. Power is I squared R. So here I squared means 1 times 1 means 1, and times R is 6 watt. 6 watt. Here 2 times 2 is 4, 4 times 3 is 12. So this is the answer, 6 watt and 12 volt. 6 watt and 12 volt, this one, the fourth one is the answer. 46, let us check the answer. 46, the fourth one is correct. Yes, fourth one we have selected. So very easy this one. So if you couldn't understand, now I am going to explain everything in detail. So let us get a copy of this circuit here. So let us draw this. Now I am taking my time because I am explaining the longer way, that means with detail. So let us first of all change these resistors, change these devices, they say, because we have to do the calculation as resistors. Even though devices, the word is devices, it is useless. So these are resistors. So therefore let us draw this one, this, because some people can't understand this due to this odd figure. So boxes, we are used to solve these types of resistors. Therefore that also will be a problem. Therefore I changed it to a into resistors, so that it will be more similar to our eyes. So we have to get the, so this one is what is the value, 6 and 3 respectively, x 6 y 3. So the values are 6 ohm, here 3 ohm. So the current is passing starting from this positive side and flows along this line, and some current goes to this way and some current goes to this way, and altogether they gather together and go to the negative side of the battery. So these resistors are therefore connected in parallel. So how to solve a parallel network? So we can draw a single resistor, that is the equivalent resistor, that is capital R. We denote it like this. So there is an equation, 1 over capital R equals 1 over R1 plus 1 over R2. This is the general equation for such a parallel network. So 1 over capital R, that is what we are going to find out. So R1 is 6 ohm, then R2 is 3 ohm. Then the common denominator 6, then 1. There are 2 times to 6, 2 times 1 is 2. Then 1 over R is that. So it is equal to 3 divided by 6. But what we want is R. So we have to invert, or cross multiplication also will work. So 6 divided by 3 divided by 1 here. So R equals 2. R equals 2. But there is another easy equation than this one. You have to keep that in your mind. I don't know what equation you use. Normally we use directly, not 1 over R, directly R equals the multiplication divided by sum. So multiplication is 6 times 3. 6 times 3. Sum is 6 plus 3. So you have, if you don't use this one, if you are not used to this equation, if you are used to this one, so you have to convert yourself to this equation because this one is easier. Only 2 lines. 6 times 3 is 18 divided by sum is 6 plus 3 is 9. So 18 divided by 9 is 2 ohm. That is the sum. That is the equivalent resistance. That is the equivalent resistance, not the sum, equivalent resistance. So now we know the value is 2 ohm here. The equivalent resistance, whatever the way, whatever the method you used to solve it, to find out it, this is the value finally we get. So battery is, the E of the battery, electromotive force is 12. They have not they have said it, electromotive force 12 volts. So it is not in the diagram, but it is in the question. So simple R is 2. So now we know these 3. The current we have to now find out what we know. We know the resistance and electromotive force and the internal resistance. So the current is this one. So now you should know the equation E equals I R plus R. This equation you have to use. So E is 12, I we don't know, capital R is this one 2, simple R also is 2, then I equals 12 divided by 4, then 3 ampere. That is how we obtained that value here. All these things I did inside my head without writing. So now we know the current. So then we have to find out the voltage here. If you are not using the ratio method, so I used here the ratio method. Ratio method is like this. It is easier. So now we know the current. So the ratio method is like this. You have to get the ratio of these two resistors. So if this one is 1, this one is 2 times, 2 to 1, or from this side 1 to 2. The ratio is 1 to 2. Here 3, here 6. So 1 to 2. So this current coming 3 ampere. Therefore you have to divide all shares, 2 plus 1, 3. So divide by 3, then 1, and multiply by 1. So that is how the current is divided. So if this one is 2, so there are 2 ampere for this place, 1 ampere for this place. This one ampere. The blue color one is ratio. But you have to write in the inverse order, not like this. 1 here, 2 other side. So 1 ampere here, 2 ampere the other side. You have to interchange these ampere values. First what we do? First we decide the ratio, and then according to that ratio this current should be divided first. So there is 3 ampere and 2 ampere here, then 1 ampere here. That is the ratio, 2 to 1. But in this smaller resistance the current should be greater. In this larger resistor the current should be smaller. Therefore you have to interchange these currents. Now that is the second step. So 2 ampere should come to this way, 1 ampere should stay here, go to this way. So like that. Now this is the current. First you divide according to ratio, and then you interchange the values, because the current should be greater in the smaller resistor. So now we know the current of this wire and the current of this wire. So what we need is now power. Power equals I squared R, that is Joule's law. So here say the current is X. Current we know already. Then 1 squared R is 6. Then 6 watt. So here the power is again I squared R. I is 2 ohm, 2 ampere. 2 ampere squared R is 3 ohm. Then 2 times 2 is 4. 4 times 3 is 12. That is the final answer. So if you don't like this ratio method, this is how you have to do. We know only the current is 3 ampere. So you have to find out the voltage here. No, before that you have to use this equivalent circuit, this one. This one you have to use. Before go to this, keep this aside. Then you know the current is 3 ampere. Then what you have to do? You have to find out the voltage. So V equals IR. We apply this equation to the equivalent resistance, that is 2 ohm. So we have to find out the value V. So 3 ampere times this resistor is 2. Then 6 volt is there. So now you come to this equation, the original one, and you place that 6 volt here, because this resistor is the equivalent of these two resistors. So this side also has that 6 volt. Then say the current is X here, say the current is Y here, assume like that. So you can again use V equals IR equation. We know the voltage as 6, the current we don't know X, R is 6, then X is 1 ampere. Then again you have to use apply V equals IR to this right side resistor. So we know the voltage is 6, the current is Y, R is 3, so Y is 2 ampere. So this way you can find out the currents if you don't understand the ratio method and if you don't like it. So this method is this is the other one, so therefore I will put it in brackets, because I use normally the ratio method, that is easier. This one also I will place in brackets because I use this multiplication divide by sum method. So however, now we know the current. So after that you have to go further the same way. The power we have to find out, P equals I squared R. So we know I is 1 ampere, so squared, R is 6, then 6 watt. Then here also P equals I squared R. The current we have found Y, the current is Y, 2 squared 3, 4 times 3 is 12. So these are the final answers, 6 watt and 12 volt. So 6 watt and 12 watt, this one you should say watt, not volt, watt. That is the power means the energy per second. So I think you can understand now. If you didn't understand at first, previously, if you didn't understand the way I solved this problem, now I explained everything in detail. There are two methods for some calculations, and finally this one is common for both methods. So children, now let us go to target question. So this one is finished now, we are done, this one is done. Children, here is our target question, the target question number 1. So what you have to do is you have to read the question carefully and try to solve the question problem without watching my video. Pause the video on your own using your own knowledge and skills. You have to solve the problem alone. Now pause the video and start. Now I am going to start the calculation. So first I will do as previously, short method by heart without writing much on the paper. Most of the things are done in my head. So I have to get the equivalent resistance. 15 times 10 is 150, the sum is 25, 150 divided by 25 is 6. 6 plus this 2 is 8, so 40 divided by 8 is 5. 40 divided by 8 is 5. Then the current is here 5 ampere. So the ratio is 3 to 2. Then 3 plus 2 is 5. Then that means we can write 3 ampere here, 2 ampere here, altogether 5 ampere is okay, but we have to change these values. 3 ampere here, 2 ampere here. Remember to change. That you can do by heart, but you can do by heart, you don't have to write, but I did it for your sake. So power I squared r, 3 times 3 is 9, 9 times 10 is 90 power. 2 times 2 is 4, 4 times 15 is 60. So the answer should be 90, 60, this one. This is the answer. So now the described method. So let us first find out the equivalent resistance. So we draw a single resistor here, the battery. So we are going to find out this capital R. E equals 40, simple R equals 2. What we want is current. Before that we have to find out the R resistance. So the first method, multiplication divided by sum. So 10 times 15 divided by 10 plus 15. 150 divided by 25. Then 6 ohm. Now we know the value of this one is 6 ohm. Now what we have to do to find out the current? So we write the equation E equals I times in brackets R plus R. So E is 40, current we don't know, capital R is 6, simple R is 2, altogether 8. I equals 40 divided by 8, so 5 ampere. This is the current coming out from the battery. So this current should be divided between these two resistors. How? You can now use the ratio method, but if you don't like it, before that I have to show you. If you don't like this equation, multiplication divided by sum, if you are used to the other equation, other method, so let us do that also. 1 over R equals 1 over R1 plus 1 over R2. 1 over capital R is what we are going to find out now. 1 over 15 plus 1 over 10. The original resistances are 10 and 15. So we can take 150, no, 30 we can take, 30. So here 2, here 3. Then 5 divided by 30. So invert to find out R. Then R equals 6. The same answer. Then you have to use this method to find out the current. This method. Now we want to find out the voltage. So let us use V equals IR, because we are not going to use the ratio method, that is why we are going to use V. Otherwise you don't want to find out V if you know the ratio method as I explained. If you like it, you can find out without finding this V. V equals I is now we know 5 ampere, R already we know 6, then 30 volt. So take that to this diagram now. You can mark that same voltage here for these two people, separate, but we write separately, but the voltage is same, 30 volt. Yeah, 30, because here the voltage is 40 given by the battery, that is E. Always when there is a current it decreases, so 30 we can accept it, it can be happen. But if it is 50 or something, you must be aware that it can't be happen, because the full voltage is 40 here, you can't get 50 from 40, so then there must be a mistake. If something lower than this value E, so it is acceptable. So now we have to find out the individual currents of this one, X, suppose Y. So V equals IR. V is now 30, I is X, R is 10, then the current is 3. So here the current is Y, voltage is 30, resistance is 15, resistance is 15. So Y, the current equals 2, 30 divided by 15. So what we have to now do, find out the power. Power equals I squared R. So here I is 3 times 3 is 9, 9 times 10, the resistance is 10, so 90 watt. Here power is 2 squared times 15, 2 squared is 4, 4 times 15 is 15 times 4, 15 times 2 is 30, 30 times 2 is 60. That is the answer, 19 and 90 and 60, 90 and 60. This one, 90 and 60. This check mark I marked it at the first time, no, when I was doing it by heart. Okay, the same answer we received from the both methods. So I have written in green color the alternative methods, whatever method you can use. So let us now go to the next target question. What happened to your answer? Correct? If your answer is correct, you are genius, but these types of questions normally we don't get in the exam, children, because due to those problems, the pandemic time we had in the past, that is why I think they have given this so easy, such a question. Normally they don't give such easy questions in the exam. This one is not actually an exam question. This one is just exercise we do normally in the classroom. There's nothing to think about, just using the methods. Anybody who has learned the lesson can solve this problem. That way they can't check your intelligence and the skills. To check the intelligence, they give normally a difficult question. So this one is actually not an exam question. So however, they have given now, don't they? So let us go to the next target question, and after that little we are going to do more difficult questions today. So children, let's go to our next target question number 2. So this one is the question. Now you have to solve. So carefully read the question and try to solve it in the way you have to follow the way that we previously used and find the answer on your own. Honestly do it without watching my video. Now pause the video and begin. Now I am going to start the calculation. As usually, first I do it in the short way by heart. So first of all, the equivalent resistance I have to find out. 6 times 3 is 18. The sum is 9. 18 divided by 9 is 2. 2 plus 2 is 4. 25 divided by 4 is 6. 25 divided by 4 is 6. Then the current is 6 ampere. Current is 6 ampere. The ratio is 1 to 2. Then this 6 ampere should be divided into 3 first, because 2 plus 1 is 3, divide by 3 equals 2. So 2 times 1 is 2 ampere, 2 times 2 is 4 ampere. 4 ampere and 2 ampere, the sum is equal to 6 ampere. Then it is correct. But we have to change these values: 4 ampere to this resistor and 2 ampere to this resistor. So let us now delete this one. So that also normally we do without writing anything, but I did that for you to understand easily. Then we know the current. So what we have to do? Find out the power. I squared R. 4 times 4 is 16. 16 times 3 is 48. Here 2 times 2 is 4. 4 times 6 is 24. So 48, 24. This one is the answer. Respectively, the power consumed by each device X and Y respectively is 48 and 24. That is the answer. So what happened to your answer? Correct. If it is correct, you are good. If it is wrong, you have to do more exercise. Again you have to do the first one. Again do the first one and get some practice, and then come to this one, then you will be okay. So now I am going to explain the long method that I do for those who has missed their lesson or something has happened, so that they can't understand the lesson electricity. So let us find out first the equivalent resistance. What is the equation? So either you can use the multiplication divide by sum. So that is what I used. Multiplication is 3 times 6 divided by 3 plus 6. Then you get 2. Or otherwise you can use 1 over R equals 1 over R1 plus 1 over R2. 1 over R equals 1 over 3 plus 1 over 6. Then the common is 6. 3 times 2, 2 plus 1, 1. Then 1 over R is 3 divided by 6. Cross multiplication or invert, R divided by 1 is 6 divided by 3. So R is 2. Both methods give the same answer. So now we draw the equivalent circuit. 2 ohm capital R equals 2 ohm, E equals 24, simple R equals 2. Now you have to find out the current, total current. E equals I times R plus R, 24, 2 plus 2, 6 ampere. Then or you can use the ratio method. So I explained it. Now I am not going to explain it again. Ratio method I will explain it here. So if you don't like ratio method, you can use this one, finding voltage. We know the current now equals IR, I6, R is 2. This capital R you have to take. Then V equals 12 volt. Then we go again to this circuit, back. We write the voltage that is common for both. Therefore I can write like this, that is common for both. Then here V equals IR, the current say Y, current suppose X, then V equals Y times 6, V means 12, here 12, 12, Y times 6, Y equals 2. Then for this one V equals IR again, V means 12, X, R is 3, current is 4. Then P equals I squared R, 4 squared R is 3, 16 times 3 is 48 watt power of X. Power of Y is I squared R 2 squared, R means 6, 4 times 6, 24. So those are the answers, 48 and 24. Here 48 and 24. So children, I think this time you must have solve the problem successfully. If so, you are genius. But if you made a mistake, or if you watched my video, then you have to follow the previous exercises again. So let us now go to the target question 3. Children, here is our next target question number 3. So start solving it without watching my video. Carefully read the question and honestly try to solve it without watching my videos. Now pause the video. I think you have done. So I am going to solve it. First, by heart, the short method. The equivalent resistance is 2. 2 plus 1 is 3. 9 divided by 3 is 3 ampere. Here the current is 3 ampere. So it is divided into 1 to 2 ratio. Then 2 ampere here, 1 ampere here. Then the power, 2 times 2 4, 4 into 3 12 volt, 12 watt. Then 1 times 6 is 6 watt. This one is the answer. Now the long method. First let us find out the equivalent resistors. First I find the multiplication, divide by sum. So we get 2. Then I calculate the basic method. I think I don't have to do it because previously I did it, didn't I? The same values like this. So no need. Previously I did it. Therefore let us skip it. The same value 3 and 6. So that way also you get this 2. And also current now we have to find out, because previously the battery voltage was not 9 volt, 24 that. Now let us do it. So let us draw the simplified diagram. This one, 2 ohm, capital R, 9 volt, 1 ohm, the battery, like this. So E equals I times R plus R. Here 9, 2 plus 1. I equals 9 divided by 3 is 3. So the current we know now 3 ampere. Now we have to find out the voltage. If you don't like this ratio method, let's find out voltage. I R 6. So now let us go back to the original diagram. So we write the voltage that we have found is it is common for these both resistors. So say the current is X, suppose the current is Y, V equals I R, 2 ampere. V equals I R, 1 ampere. Now power, I squared R, 3, 12. P equals I squared R, 6. 12 watt, 6 watt. Again we received the same answer. So you have to practice this way also, because in essay papers you can't do this way, then you have to do all these things like this. Therefore it is not in vain if you practice these things. It will be helpful in your essay paper. So now let us so what happened to your answer? I think you must be now successfully selected this fourth one, I think, because this one is the third one. We have done previously 2 exercises, and with the original one 4. So this time you must be correct. You must be correct this time. So let us go to the next one, question number 4. Children, let us go to now the target question 4. Now read the question carefully and start to do the calculation. Pause the video, honestly do it. I think you have found the answer. Now I am going to solve it. So as previously, what they ask is the power lost. Power is lost by this internal resistance of the battery. So we have to find out that. So this one is simple R. The power loss is I squared simple R. Due to simple R in the battery, the power is lost without going to these resistors. Resistors means they are resistance, they are devices actually. So we have to find out the total current as previously. So the equivalent resistance is 2 plus 1 is 3, so 9 divided by 3 is 3 ampere. The current is 3 ampere. So we don't have to go here now, we don't have to divide the currents to each resistors, because through the cell the current is now 3 ampere. So we can use directly that in this equation, because through this internal resistor the current is that one. So power lost equals therefore 3 squared times 1, so 9 watt. This one is the answer. So I think I have not to explain more, this one is easier. If you know this thing, then you can find the answer easily. If you knew that the power is lost by the internal resistance of a cell, then you would have easily find out the answer. So now that is enough. I think I don't have to show how this 3 ampere is received as if previously. So we have done all these things in previous problems, the same values. Therefore I can conclude the question now. So let us go to the next one. So children, now let us move to the question number 5, target question number 5. So read this carefully and try to answer. So I have changed the question. So this one is a real examination question. A battery of e.m.f 6 volt and internal resistance 1 ohm is connected to a variable resistor as shown in the figure. The resistance of the variable resistor can be changed from 0 to 5 ohm. By adjusting the value of the variable resistor, what is the maximum power can be taken from the resistor R? So pause the video and try to find out the answer on your own honestly. So children, to solve this problem you have to use a different type of theory pattern. In the lesson you must have learned that the maximum power is dissipated when simple R equals capital R. This is the condition. If this condition is fulfilled, or otherwise I can write the capital R equals simple R, then we can get the maximum power through that capital R resistor. So this knowledge you should have to solve this. So therefore they have not given this the exact value, they have given only a range. So you can't take either 5 or 0. You should know this one. So what is the internal resistance of the cell is 1 ohm. So therefore you have to adjust this variable resistor until you get the value 1 ohm here. That means R equals 1. So now we can find the current and finally we can find the power, that is the maximum power. When the value of this capital R is equal to 1 ohm according to this question, because the internal resistance of the cell is 1 ohm, then we get the maximum power. So current to find out equals I R plus R as previously. So 6 volt I R is 1, simple R also is 1, capital R is 1 due to this relationship. So I equals 6 divided by 2, that means 3 ampere. Now the power from this one is I squared R. So this power is maximum. We can't get more power than that. Maximum power is 3 times 3 times 1 ohm. So 9 watt. That is the maximum power that can be taken from this resistor, this one. The answer is 9 watt. So if you know this theory, it is not a big question. Other thing, you should know this equation, then you can solve this easily. So now let us go to the question number 6. So now let us go to the target question number 6. Here is the question. So read it carefully and honestly. Try to solve it. Pause the video. So children, now I am going to solve this. What they ask is not the power of these resistors, what they ask is power of the battery. So you must have learnt it. Power of a battery is given by this equation. It is equal to E times I. This is the equation to find out the power of the battery. So if you don't know this one, sometimes you may not be able to correctly answer this question. Sometimes you might, if you have the intelligent power, sometimes you might answer, but without learning, I don't think you would be able to answer. So this one is the power of the battery. So you know already the E is 9 volt. Therefore we have to find out the current. So 6 times 3 is 18, divided by 9 is 2. 2 plus 1 is 3. So 9 divided by 3 is the current, 3 ampere. So you don't have to find out the individual currents in each resistors, because we have nothing to do here. We have only to calculate around this area. So the current through the battery is 3 ampere, that is enough. So I is 3, E is 9. So 9 times 3 is 27. That is the power of the battery, power consumption of the battery, 27 watt. The third one is the correct answer. So I think that is enough. We don't have much to talk about because we have done everything in previous problems. Only this one is new, so I explained it. So let us go to now next target question. So children, now let us go to the next target question, question number 7. So here is the question. You have to read it carefully and try to answer it honestly. Pause the video. So how to find out the efficiency? What is the equation? Efficiency equals power output divided by power input times 100. If you know this equation, you can find out the efficiency easily. So power that is useful, that is the output power, useful power output, useful power output. So the useful power is given by this resistance. So this one is not useful because it is used to heat up the cell. We can't use that for any work. So therefore the current we know already from previous problems. We have solved and found the current. Here we don't have to do. The equivalent resistance is resistance is how much? 2 plus 1 3, 9 divided by 3 is 3 ampere. So the current we have to now find out. The current is here 2 ampere, here 1 ampere. So power is I squared R, 4 times 3, 12 watt. Here power is 6 watt. Then altogether total useful output power is 18 watt. So you have to substitute 18 here. What is the input power? So input power means the power given by this battery. In the previous question we solved it, we know it, EI. So that one, that is 9 times current is 3, then 100 here, 18 divided by 27 times 100. So I am using the calculator, but you are not allowed. Teachers can use times 100, 66.6 percent. So the answer is this one. So children, I think you understand, you can understand. You should know this equation to solve this problem. If you know that, easily you can solve it. So children, let us wind up for today. So children, if I go to a conclusion, first we solved this original MCQ question number 46, and then we did this target question 1, and then we did this target question 2, then this target question 3, then this target question 4, then this target question 5, then this one 6, and also this one 7. So we have done today 8 questions. So I think you are happy. So you have to make me happy too. So what you have to do, you know, if you haven't still subscribed to my channel, please subscribe it. But if you have already subscribed, don't press that button again, then it will be cancelled. So what else you have to do? Share my link among your friends, so you can make my audience a little bit larger. And also you can press the thumb up button to give me a like. So if you give me likes, then my videos will be spread among children, so that it will be helpful to them. And then you have to press the bell icon, so that you get the message as soon as I uploaded the video. So no time is waste then, because we have little time. I think there's no 80 days to the exam. So children, thank you very much for watching my videos, and also thank you very much for those who already subscribed my channel, and see you tomorrow. Goodbye children.